Hey, what's going on? I'm Will from DevOps for Developers, and in this video, we're talking about AWS Identity and Access Management, or IAM. IAM controls what people and applications can do with the services and data in your AWS account. It's critical for security, but it's also really hard to get right. Recently, I sat down with Kuenzli from K9 Security, and we chatted about AWS. And I'll be honest, I've been working with AWS for over 10 years, and I learned more in this 30-minute conversation with him than I have in those past 10 years. I also happen to be recording it, and so I'm just going to jump right over to the recording now, and I think it's going to help you demystify IAM and put you on the right path. So let's go check that out. And the very first thing I asked him, what's the most important thing for you to know about IAM?
The most important thing to know is that security policies attached to identities get all the attention, but resource policies attached to data sources are the quickest and most powerful way to secure your data. Resource policies can protect your data from over-permissioned IAM roles, and that's what we're going to show you today. And this is important because the top IAM mistakes are really all about access permissions. It's really easy, and AWS makes it so, because they want you to get up and get that quick hit of success. AWS makes it easy to allow permissions, but it's really difficult and tedious and error prone to allow access to just the right things. So the top three mistakes are allowing access to all resources, allowing identities, IAM roles and users access to all actions, and then on the data side, allowing access to all principals, like a public bucket. So this is so hard, and I hate this problem so much, I wrote a book to help you out.
Right on.
It's called Effective IAM for Amazon Web Services, and it's a free book. It's at effectiveiam.com. You can go there, and we're going to go through this and learn about IAM. How does that sound, Will?
It sounds great.
Okay, cool. So what a lot of engineers who are building apps on AWS, they start with this problem of like, okay, we have an application and we need to deploy it, and it needs to access some S3 buckets so it can store some objects, some data files, or maybe it needs access to a database or something like that. So as Will said, IAM controls whether or not that access can happen. And at a high level, we have what's called an IAM principal, which is an application or person that has been authenticated to AWS. And those principals there are two types of IAM principals, an IAM role or an IAM user. And IAM decides whether or not that application or person can issue an API request. AWS calls these API actions. So we have a principal that makes an API request to a resource. So we have principal, action, and resource. And IAM decides whether this is going to be allowed or denied. So you can have very fine-grained security policies, or you can have very coarse-grained. And so what we often end up with is people, to get things working, they deploy very coarse-grained stuff. And then, so you have basically wildcards allowing all API actions or allowing access to get objects from all S3 buckets. But the key is to remember that at its core, AWS IAM enables you to state with a security policy whether a principal should be allowed or denied the ability to invoke an API action on a resource. And all security policies in AWS have this form, this one form. There's a JSON document. And if you're writing in CloudFormation, this gets converted to JSON. And there's one-to-many statements in that policy. The most important of which usually is the principal. Who does this principal allow or deny access to? And you can specify AWS IAM principals. You can specify services like other AWS services such as CloudTrail. It's really common to allow CloudTrail to deposit audit logs into an S3 bucket in your account. And then you specify whether the effect is allowed or denied. So, your application role is maybe allowed to execute S3 get object. And then you can say on what resources, an S3 bucket, all S3 buckets, a particular object. You can use wildcards to fill this in. And we're not going to go through all of this stuff, but the key takeaway is that because there's there's a lot here, right? You can use wildcards in your resources, in your actions, etc. And so this is where people get kind of tripped up. And they resort to using a managed policy, an AWS managed policy that just gives a whole bunch of access.
Right.
Does that make sense?
Yeah, totally. You're pretty much describing how I've built most of my IAM policies in the past.
Yeah. Yeah. And we're not going to there's actually 5 different kinds of policy. We're only going to really talk about 2 of them today. One is an identity policy. And those are policies that if we go back up to the top here, an identity policy is attached to that IAM principal, either a role or a user. And then there's a thing called a resource policy, which is a security policy that attaches to a data source like an S3 bucket or a KMS key, which controls access to data. Having spent years doing this, I can tell you the identity side is kind of a train wreck. There's managed policies granting all kinds of access all over the place. But you usually have only a few critical data sources. And you can usually wedge a resource policy into this request flow so that you can control and protect your critical data with a control right next to your data. So that's what I'm going to show you today. So if we want to control access to an S3 bucket, we could try to get all the, say this S3 bucket right here has sensitive application data in it. You could try to get all the identity policies in your account to not have access to this thing.
Mm-hmm.
That's what a lot of people do. And that's what that first, meme image was about. Ooh, identity policies, they get all this attention. Least privilege identity policies. But there's another way. You can use resource policy to control access to this thing, because the way IAM works, this is quite a little eye chart of how how IAM determines whether something's allowed or not. But the key is that there's basically 2 ways to allow access: a resource policy or an identity policy. And there's another key thing that you need to know about IAM, in that if you ever have a deny in a policy that applies, the deny always wins. So you start off IAM, a principal doesn't have any access, and then you apply various security policies to allow some access. But if there's ever a deny, the deny wins.
Right on.
So what you can do in this scenario is you can put a resource policy attached to your bucket, attached to your encryption key, that allows just the application or person that you need, and including your CI/CD systems. You can allow just those principals to have access to the bucket or key, and you can deny everyone else. And there's one place to essentially control access to that data.
So then no matter what new future policies ever get built, that they're not going to be able to override that resource policy, right?
That's right. Because the resource policy, the resource policy will, number 1, always be evaluated. And number 2, deny always wins. So the trick is you actually have to create a pretty interesting policy. So now that I've convinced you that we should use resource policies to protect data, let's start with a classic security approach to implementing least privilege, which is we want to disable all unwanted access. So say we start our resource policy with a deny everyone else statement. So we're gonna get to the allow side, but let's start with by denying all unwanted access, and say, like kind of described before, maybe we have, we've got our application, and we've got like a CI/CD system that needs to deploy things, and then we have just like operations administration. We have an admin role to administer the app and its data for people, and maybe we have a customer service role that needs to be able to like read the data sometime. Okay, fine. Like we'll carve a hole in our access controls for those folks, and we're going to deny all other access to the bucket. Okay, now we can go and specifically allow certain things. And we can do things like disable the ability to access the bucket insecurely, without using HTTPS.
Right.
We can enforce that. There's some stuff there. But like, let's go ahead and put the allows in here. There's like a general form that we can use. And I recommend this general form for statements so that you understand, it's easy to read this policy later. And so we want to say things like, we want to allow some sort of capability, like allow read, allow write, allow delete. And that's a good way to group the API actions, instead of it just being kind of like a big mess, and like a bunch of different kinds of access capabilities all mixed up. So like a real example would be like, say we want to allow writes to the bucket by the application, and we only need the application to write to the bucket. We could add a statement that looks like allow restricted write data, and it can do put object. It's going to specify the resources that it applies to, and it's only going to allow this app role. And so now the only thing, that's going to be able to, the only principal that's going to be able to write to this data store, is the app role. That's all we've allowed so far. And we can kind of repeat this pattern for administration. And here we're going to give the CI user and the admin user these capabilities. And this is like, this 25 actions or whatever. This is like what it looks like to enable administration access to a bucket. It's like a lot of stuff.
Right. And the thing I like here is that it's still all spelled out. I mean, you still manage to grant the permissions necessary without resorting to the wildcard star.
Right. And that's important because like if we were just to say S3 put star configuration, well, what's going to happen is that over time, as AWS releases additional ways to administer the bucket, we might like start getting privileges that we didn't expect. That happens. And, so you'll see a lot of folks doing like S3 put star. Well, like S3 put star, that not only allows putting data with like S3 put object, but it also allows changing the replication configuration and, like the lifecycle configuration, which is really important because like that's, you can configure rules like whether or not data just gets deleted automatically, like after a year or 7 days or whatever. That's what lifecycle configuration does. So like, you don't want the application to be able to decide that. That's very much an administration thing. And I'll tell you what, like, so this is a general pattern for implementing least privilege access to data. So we use a specific common example of creating a bucket policy. And I'll tell you what, like, here's the full, the full bucket policy. It's like 200 lines long or something. It's here in the book. Read it at your leisure.
If you need a little easy reading before bed one night.
Yeah. Like go and bask in its glory. And I'll let you know a secret here. I am full time. It's like it's maybe a little unhealthy even. And I'll tell you what, I cannot write this policy myself. Okay.
So I think that's key right there. I mean, if you're saying I can't write this policy, how's everyone else supposed to manage this?
You should use the library I wrote to generate the policy. So
nice.
So this, I literally didn't write this policy. My company has created free infrastructure code modules that allow you to write your permissions in a very declarative and high level language, where you say like, these are the administrators I want to allow, right? We define them as variables. These are the folks who should be able to read the config. These are the folks who should be able to, read data. And then you pump it in to your bucket configuration. And then the library takes care of generating that policy, because like humans can't do it.
Oh, that's super cool.
Yeah. Like, truthfully, like I've never written that policy by hand. I've only created libraries that can generate that policy.
Oh, that's super cool. And now one of the side benefits of that is it's all documented as code. So two things, like one, if it ever does get changed manually, you just reapply that policy and everything goes back to the way it was. But then you've also got your job history to see what happened to make changes to it.
Yeah. And you've got in your code, what you've got in your code is something intended for humans to read and write and review in your delivery process. And of course you can, if you have like the ability to generate Terraform plans or review Terraform plans, you'll also see the fully generated policy, and you can diff those, and Terraform will like give you the diff of like what's changing. I actually did that this morning. Like, oh, okay, great. Like, no changes. I was reconfiguring a KMS key, but like now you have two levels of understanding here. You have like the high level intended for use by like your entire cloud team, your application engineers, your security team. Everyone can understand this kind of language.
Yeah.
And then you can inspect a fine-grained diff for, the actual least privilege thing. And that really lifts the load. Using infrastructure code libraries in this way really lifts the load of what it takes to secure things.
Yeah, that's super cool. I mean, that feels manageable, which is something I've never been able to say about IAM.
Yeah, right. Like, and like the key to security is that like, in order to like secure things at scale and with continuous delivery, we're going to need to make it all usable by non-experts. And so that's what that's been my mission, to like make AWS IAM usable for cloud teams for the past 3 years or so. If you want to learn more about this like approach, there's this, believe me, we go deep in this like simplify AWS IAM like chapter. And actually here's the details. Chapter 5 is the details of like how and why this works. Technically, this is called, what I just showed you is called a resource boundary. If you want to impress your security and DevOps expert friends.
Right. Drop a little buzzword.
Yeah. Drop resource boundary. But like, I'm going to explain resource boundaries to you. Like, let's go. But like, there's all kinds of details here about like why AWS IAM is so hard, and then like how to understand what your policies actually do. Like, if you think about that policy evaluation logic, guess what? No one actually understands like how to process all the policies, all the identities, all the data sources, all the rules of, IAM is very powerful. It's very nuanced. Like how do you understand what the access really is? So there's a chapter on that too. So what we've tried to do is make this as a resource, make effective IAM as a free resource for DevOps, cloud, site reliability engineers, security engineers who are writing policies or needing to understand them, to make your lives much easier, and like basically identify a few strong patterns and like levers so that you can apply those all over your deployments, and get really good at those few things and really lock down your environment in the way that you need to.
That's super cool. And I think it's going to be, it's already important, but I think in the next couple of years, we're going to see that become more important, because it just feels like we're on the edge of seeing some wide scale security breaches just ready to go viral.
Yeah, I mean, it's already happening. And,
Yeah.
the security to some degree, but like security has always had this problem of like, well, how do we scale? And I think that integrating security into your delivery process with like easy to use libraries, like I was just showing, and like the approaches that are talked about in this book and this session, um, I think that's how we end up scaling security. We have to make it usable by not just security people, but cloud, DevOps, and especially app people, because they're the ones that actually understand what the access should be. Like, yeah, like this is my critical data store, and that application should have access, and that other application should have access, and no one else.
Yeah. And there hasn't really been a good way to do that up until, like, literally for me, until I saw you demo this library here this morning. I've
Yeah.
always struggled with that. In the past, it's been application team that writes the code, knows what the security is. And then if you're fortunate, there's a security team involved who looks at it, and maybe they understand what's going on, maybe they don't, and they give it their best effort.
Yeah, and I'll say that I think in practice, and like I've interviewed a lot of engineers of all titles working with AWS. And by the way, I'd love to interview you too. There's an offer in the book. Like, I would generally love to talk to you. But it's the people who are actually writing and authoring policies right now in 2022 and going back to 2019. It is like 90% of them are DevOps and cloud people, cloud engineers, and about 10% security engineers.
Right.
And it's because you're so close to the cloud, like you have the keys essentially. And you're often working with security engineers, but they may not have like practical policy writing experience, IAM policy writing experience, and they're going to basically trust you to do it. I mean, they trust you, right? You're on the same team, and so understanding how to manage access to cloud data is really important, and that's what we hopefully helped you get a head start on today.
That was super cool. So your book, is this the website for it, effectiveiam.com?
Yeah, effectiveiam.com. There's, the web version is free. You can also buy a PDF, and soon there will be an ebook version. But I actually just really want to get this out there into the world. And if you have questions, like, please, like, hit me up. I'm S Kuenzli on Twitter. There's a little Twitter icon right here. Or if you want to have a chat and discuss AWS security, do that too. Like,
that's awesome.
Would really just like love to hear about what your problems are, or like what you're trying to solve.
Now, I'm excited about this because the channel here has a lot of people just getting started in DevOps, and IAM is one of those topics that I haven't really covered a whole lot, just because in my mind, it's always been this big rat's nest of tangles and wires and stuff. But, just in a few minutes we spent here talking about it, I feel like, oh, okay, this is something I can wrap my head around. And I think it's something that people just coming into DevOps can wrap their head around. And in this format, it's consumable, and it's something that they can just look at, spend a little time learning, and then go out and apply it over and over and over again.
That's right. That's right. And, especially when it comes to infrastructure code, we get the value out of using and reusing a solution. So, you can protect your data by using a good solution that you picked up off of GitHub that's supported, that everyone understands, or, implement it yourself, but like make sure that it's giving you a building block that fits well into like your overall application architecture, and like all your reference architectures. So, you don't need to use, and I highly recommend you don't use more than a handful of IAM's features. Like, it has many, many features, extremely powerful, but you just don't need them.
Right.
You need them all. Like, and that's what Simplify AWS or Simplify IAM, but using the best part, is all about. And so, yeah, I'm glad that even you, Will, who've been using IAM or trying to use IAM for years, but you picked up some things today.
Yeah, for sure. I totally did. I totally did. This was super cool. And then I will drop links to your book in the video description down below. And yeah, thanks, man. This has been super insightful.
Yeah, well, you're welcome. Thank you for having me. This has been
Anytime.
It's been great to be on the show.
Right on. Cool.